welcome, folks, to another HDR UK Applied Analytics seminar. Quite a few people will be familiar with this. I see a few new names and so on. So the way it works is we have a seminar speaker. As in this case, it's Heidi Seibold, and she'll be talking to us about the Turing Way and all of that. We normally have the talk for about 45 minutes or whatever that turns out to be, and then we'll try and leave 15 minutes for or thereabouts for questions. And if you were listening to Heidi just now, you can either do it through the link that she sent, or just type something into the chat, whatever you prefer, and we'll just busk it once we get to the questions. So if you're happy, Heidi, if you could take it away, that would be great.
Awesome. Thank you so much. And thanks for having me. And I'm going to start sharing my screen now. I'm going to talk today about the Turing Way, which is both a community, but also a handbook for reproducible, ethical, and collaborative data science. My name is Heidi Seibold. I work at the Jona Institute, which is a company that deals with certification of medical devices and does consulting in this area. And we're growing the research group within the company now. And I'm also an independent researcher with ICDOR. And also you can follow me on Twitter under @HeidiBaya. So today I'm going to be using this HackMD where I've also pasted the link in the chat. And I would like to spend a few moments to get some answers from you on what your background is and whether you know the Turing Way already. So if you could go to that link, and then I'll stop sharing the slides and also go here. So if you click on this button here at the top left, then you can see what I see, and then you can just start writing in here whatever you'd like to share. So the first question is, why are you here today? Then the second question is, have you ever heard of the project, the Turing Way, before coming here? And if yes, where have you heard of the Turing Way? What is your connection to the project? And then last question is, what do you expect from the seminar today? And if you could all take a few moments and try to answer these questions for me, that would be a great help to me to understand, yeah, why you are here and what you expect from me today. Excellent. So I see nobody else writing, which is why I assume that you're done. If you still want to add something later, feel free to do so. You can both ask questions here, and I see that people are already adding questions, or in the chat, whatever is easier for you or wherever you feel more comfortable with. So I see, how can we contribute to the Turing Way? This is a question that I'll answer throughout the talk. How do we balance expected convention against the use of best practice, especially if a method is relatively new? This is something that we can definitely discuss later. It's very interesting. And how do we integrate reproducibility very deeply into workflows? Is something that we can definitely also leave for later. So I have tried to keep the me talking part relatively short so that we can have a little bit more of a conversation later on. And I'm very much looking forward to discuss with you. So I'll go back into presenter mode. And get started. So what is the Turing Way actually? So as I said, it's both a community, but also an online book. It's an online book that has several different parts, and it started as an online book for reproducible data science. And this is also how I got into it, because I'm interested in reproducibility, and my background is in data science. But by now the project has grown so much, and things like project design, collaboration, ethics, and also community and outreach have become parts of the book. So it's grown into something that's more complex, but also more holistic view on how we can do data science in a better way. So that's the Turing Way. So if you go to the Turing Way website, this is what you see. So it's an online book. It's really like a book just in a website, essentially. And on the left-hand side here, you see the different parts. So as I said, reproducible research, project design, communication, collaboration, ethical research. And then there's this one part that says community handbook. And this is essentially a guide of how the Turing Way is done, because the Turing Way itself is like this big, really cool, modern, collaborative project that people can definitely learn from, as I see it. And I think this is one part of the Turing Way that's also very, very interesting. And I'm happy to talk about that as well. So yeah, these are the different parts. You can read it for free online, and anyone can contribute if they want to. So how did I get into this project? As I said, my background is in data science, and more over the years, I started to be interested in best scientific practice, right? So my first research project that was still during my master's was in the end a total mess of files that were flying around everywhere. The file names were super unclear what the files contained. But then I talked to someone and he said, well, that's kind of normal. And everyone struggles with this. But I wanted to do better, and I wanted to be feeling like I was doing a good job. And also, like, you always get reviews back, right? So after getting the reviews back, I was like so confused what all the files were, what I needed to do to update my results according to the reviews. And I just wanted to do better. So that's how I started to get interested in reproducibility. And with this also more and more over time with open science, open data, open code, because reproducibility for myself, I could do within my own little project on my computer. But when I started thinking about reproducibility for others, so if I, for example, want to reproduce something that someone else has done, I need to be able to access their stuff. So their code, their data, their materials in general that they used for the research. And I also started getting really interested in community things. I started an R user group back in Zurich, and I was really excited about the fact that, the research community was so vivid and so exciting and so many interesting people. But I felt like that was also pretty hard work and not always easy to get everyone involved and make everyone feel comfortable being somewhere, especially like in coding communities. There's usually many men, and I wanted to make it feel, especially also for other people, to feel welcoming, and this is how I got into this. And so all of these things made me very, very interested in the Turing Way. So this is exactly what the Turing Way to me is about. All these data science, reproducibility, open something, and community building is something that I think the Turing Way just is like the greatest project of. And maybe I should mention here that I'm not anything like a leader in this project. I'm just one of the contributors and one of the people who are excited about it. So I have no big stake in this. And the way I heard about it was through some online events, through Twitter, and I got really excited about it. And at some point I applied to be involved in something that's called a book dash. And that's actually an event that's really, really cool. So we went to this book dash in 2020. So you might see at the bottom here that the photos are from the book dash report from February 2020. So this event was actually the last in-person event for me before lockdown, and it was great. So I'm really happy that this was my last cool event that I had before, COVID hit. And so what is a book dash? A book dash is an event where people come together for very short amount of time. I think we had 2 days in total. So one afternoon, one full day, and one morning. And we really, what we did is work on the book, improve the book, write new chapters, collect ideas what the book could be in the future. And also, as you see in this picture here in the back, we had someone there who helped us with creating cool images that we could use for the book as well. And there were some people here that you see on the little screen that participated remotely. They couldn't come to the event itself, but they formed a small group in the Netherlands and participated from there, which was really cool. So this was really the event where I got really involved in the project. I had heard about it before. I had contributed here and there a little bit, but this was really how I got really involved. And and now I want to talk a little bit about the things that I did through my work in the Turing Way. And as I said before, my really big interest in the Turing Way initially was reproducible research, because that's like my big topic. That's what I'm really interested in. Before I dive into it, I want to talk a little bit about what we in the Turing Way, or what I also mean when I say reproducible research, because that's a bit of a confusing term and people use it in different ways. So I want to quickly just say what it means to me. So to me, reproducible means when I use the same data to do the same analysis, and then if I get the same results, then I call something reproducible. So imagine you have a data set and some R or Python code, and then you run that code on the data, and then you get a set of results. You want that set of results to be the same as in, for example, the paper where you took the data and the code from, right? And that's, in my view, a real minimum standard, or it should be a minimum standard. But that's already pretty difficult. So imagine, for example, you use an R package that's a different version from the people that wrote the original code. Then already through that, the results might be different. Imagine that, for example, maybe the authors uploaded a version of the data that's not exactly the same as the version in the data they used for the original analysis. There's all these little mistakes that you can make that are mostly like, organizational things, but it's not always easy to make something reproducible, at least over a longer period of time and to other people that are not yourself. So this is what I mean when I say reproducible. So what did I contribute to the Turing Way in this sense? This is what I can talk about best, but we can also later on talk about a few other things if you're interested in that. This first chapter that I contributed to is called Research Compendia, and this is a concept that I find very intriguing. So it sounds maybe more complicated than it really is, but what does it actually mean, a research compendium? So a research compendium is essentially a folder on your computer, and it's organized in a smart way so that everyone from the folder and file names understand what it contains. It usually has a README that explains all the different files that are contained in the folder. And the idea is to have all the data, all the materials, all the code in this folder, in this research compendium that you need to reproduce the results of a project. So this can be very small if it's a small project where it's very clear, this small data set, this one R code, and then a README to explain these things, but this usually is already pretty complex, right? My own research projects were always much more than that. I usually also wrote some functions, some further code to like maybe even an R package that I built throughout the work that I did, because if you work in a methodological field, you usually come up with new methods, and then you first need to implement them. Then you have raw data that you still need to clean. Then you have the clean version of the data, or maybe you have even several raw data sets that you combine. Then there might be some protocols that you need to have contained in there for people to really understand what the project is. So lab notebooks, for example, stuff like this. So the idea of this research compendium is to really contain all of these different things that you might want to know about a research project in order to be able to reproduce it as someone who didn't do the research project themselves. So this is something that I'm really excited about. And you can take this from like this very simple level as from seeing it just like a folder that contains all the things into something that's more complex. So imagine that you even have something like a Docker file in the folder so that you can literally just run, push one button, have a make file in there and push one button, and then out the paper comes. Yeah, so this would be the gold standard that I would love to see in the future from like the more technical people at least. But this is something that's really, yeah, this is not what I expect of people, but something that I would aim for in new projects. So having really just in the end, one command, one button that you need to push to reproduce from all the different files, from all the different data sets, the code, I don't know, Markdown or LaTeX files, and get a paper out that contains the same text, the same information, and also the same results in there than the original data, the original paper. So this is something that I really enjoy, this idea of research compendia, which is why I really wanted to write this chapter and add it to the Turing Way. Another chapter that I contributed to is called Naming Files, Folders, and Other Things. And that was really born out of like my, out of my learning from my first project, is that one big step in getting yourself organized and making stuff reproducible is just like having good names for your stuff on your computer. And this is such an obvious, simple step, but one that helps you so much in the end, that I really felt like if we're talking about reproducible research, then this should be part of it. And so essentially, you see it here on this slide. Essentially, you want to use better names for files. So instead of having my abstract, you want to, for example, maybe use the date and then the word abstract, but what was the abstract for example, for my slides, for example, I always use the year, the month, then where I gave the talk and what was the topic of the talk. So for today, I have 2021, 10, HDR UK, Turing Way. This is a good name for my slides, because then the slides sort themselves automatically in a way that is useful to me, because I usually know more or less when I gave the talk. And also it's informative as to what it contains. Another example is that we shouldn't use like spaces and punctuation through file names, because then it's always difficult on different computers. How do they see it? It's not so easy to read it into R, for example, use it on the terminal. This is just like a convenience thing that makes it easier to use if you don't have spaces or punctuation. Also, just don't name your things in a way that is like, can be anything. Figure 1 is not a good name because you don't know what the figure contains. If you want to use enumeration and show like which is figure 1 and figure 2, you can definitely do that, but also add maybe something like, it's a scatter plot or a histogram, and also maybe what does it plot. So that just makes figuring out things later on, because you will definitely forget what figure 1 is, right? It will make things later on easier for you, and also of course easier for other people to use. And then this last one is something that I really like, because it says delete this and your career is over. And here you again see that there's weird characters in there. This sometimes leads to weird issues with files. Just try to use things that are easy to understand, that don't use characters that are not usually used in file names, like stars and eds, and this is something that's meant for something else on a computer. So just use numbers and letters. And if you are in Germany like me, there's also usually people love to use those umlauts. This is also something that doesn't work across different computers very often and leads to a lot of mess a lot of times. Okay, so these are the 2 chapters that I contributed to, so which is a very, very small part of the Turing Way. But I just wanted to share that with you. So the Turing Way, again, is not only reproducibility, not only reproducible research, but also project design, collaboration, communication and outreach, and ethics. And these are obviously very important parts as well to doing great data science. Okay, so now I want to take the time to see if there's any questions so far that fit with the first part of the talk, to loosen this whole thing up a little bit. I'll check if there's something in the chat. Okay, so contributing will be something that I'll talk to in a minute. Maybe we could talk about how do we balance expected convention against the use of best practice, especially if a method is relatively new. Okay. So the way I understand it is that the question asker is worried about going against the norm with using methods of reproducible research. And I think to a certain degree, trying to work reproducibly is just like, doing science right in the right way. But definitely at some point it gets very technical. You might want to make your work openly available, and then it starts to be more complicated, especially if we're talking about, for example, data of patients, obviously, right? So if that's the issue, then of course you have to stay within the law, obviously, and within ethical reasoning. So I've also been working in the medical field for quite some time, and I've always felt like there's a certain balance that we have to keep, right? Because we want to keep the privacy of the patients, but also the usefulness of the science. And in my opinion, the science isn't useful if nobody can check what we did. And a good alternative for example, publishing patient data is to use simulated data that looks similar to the original data, but where we can't figure out who the patients were because it's simulated, right? So this is definitely an extra step that you would need to do, but I think this is the path we want to go in the future, and we don't want to throw research away. We don't want to throw tax money away, right? So I think it's worth the extra effort in making sure that our work is understandable for other researchers and checkable for other people. So I'm not sure if that answered the question. let me know if it didn't. I'll move on to the next question, which is, how do we integrate reproducibility very deeply into workflows, especially when joining teams or working on short-term projects? This is a very good question. It's definitely easier if you're working by yourself or with a small team where your collaborators have a similar skill set to you. But one thing that I always try to do is, for example, use version control, and this is definitely not something that everyone knows how to use, right? So there's definitely either a learning curve for the others, or I just try to do the the version control stuff on the side for myself, and just work via sharing files via email as the others want to do it. It depends really on the kind of project that you're in, on the kind of people that you're working with. I always try to get a certain level of being able to collaborate in a smart way, because if you're sending around files with emails with files, then that also leads to delays very often, because imagine you send out a file, for example, with the text of the paper, and then you ask people to give comments back, and say there's 10 people who give you comments in a Word file, say, right? And then you have these 10 Word files that you have to consolidate, which takes you much more time than if you would get just pull requests on GitHub or GitLab, right? So there is a certain element of how do I get others to collaborate with me in the way I want to be working, and also are there maybe some things that I can let go of or do for myself, keep myself organized in a certain way, and let the others do whatever crazy things they want to do. I hope that answered the question. Again, just let me know if it didn't. Okay, the next question is, I'm a big fan of reproducible research practices, but I was wondering if you think there's ever a risk of a focus on reproducibility detracting from other important things to focus on in research. For example, you can have a badly designed study / analysis which is reproducible, and how you make sure to get the balance right. This is a very good question. So I got very, very interested in reproducible research, and that definitely led me to meander sometimes in like figuring out what the best tools were. And I mean, I just really like fiddling around with like make files and Docker and stuff, but it definitely takes time to learn all this technical stuff. I think in the future we will have tools that make it much easier to work reproducibly. I just believe that that's going to be the case, because right now working reproducibly is sometimes it becomes very technical if you really want to go very deep into it. So it does it did distract me personally at times. I don't know if I have a good answer on how to get the balance right. I definitely think that a good study design is more important than having a terrible reproducible result, right? If you try to do good work and do it as reproducible as you can at that moment, or maybe you have a research software engineer that you can talk to, that could maybe help you to get things in a better shape without you having to do it all by yourself or having to learn it by yourself, then that might be helpful. So I think that in the UK, you're in a much better position, because there are research software engineers at many institutions who can help with these kinds of things. And this might be a good option to use if you're worried about having to learn so many technical things. Things like having good names for files is easy. So this is not taking any time from you, and it's something that you can do easily. Okay, getting to the next question. In your opinion, what is stopping us from doing this? Tools, mentality? Do you think researchers need external pressure to get everyone working in the same way? Okay, this is my personal opinion. I have no evidence on this, but I really think that it's a bit of both. So really, a lot of people want to push out papers as fast as they can. And there's good reasons for that, because that's how we're measured in terms of how good we are as a researcher, is like the number of our papers or high impact papers. So this is definitely mentality, and this is something that I'm working very hard to change. But also tools, right? If the research workflows were set up in a way that it's just so easy to work reproducibly, then it would be a no-brainer. Everyone would work reproducibly, because nobody thinks, oh, I want to publish research that nobody else can reproduce, or that even I myself can't reproduce in 2 months. So nobody wants to do that. But it's just like right now, sometimes the tools get very tricky. You have to be aware of many things. For example, as I said earlier, sometimes stuff isn't reproducible anymore in a few months because the version of the software changes. And this is something that if you're not very deep into this topic, that you just don't think of it, right? And so this is something that I think we could definitely improve, and that I think people are already working on. Also, things like Makefiles or Docker are very technical tools. So Makefiles are essentially, for those who don't know, are essentially text files that give you information about what file you want to create from which other files, and what the command is to create it. And that's something that people who work with the terminal on Linux or on a Mac, or they understand what that means and how to deal with that, but not everyone does. And I don't want to expect that from everyone, but there might be in the future other tools that make it just very easy, like in a click and drag and form, to just create files like these. Or also Docker, which is essentially you create your own little virtual computer on your computer to have like this stable computing environment. This is still something that's quite technical, but I can imagine that to be much easier in the future if people build better software for that. So yeah, I think my answer is a bit of both mentality and tools. But I see that this is changing and that this is getting better every day. And also, of course, things like the Turing Way, resources that help people get the information in an easy to grasp way, and also in free. It doesn't cost you any money. This is, I think, a step towards making reproducibility too easy not to do. This is, I think, a quote we have in the book. Okay, so that's it with the questions in the pad. I'm going to check the chat if there's any more questions here. Okay, I don't see any right now. And then I would like to ask you to go back to the HackMD and answer the intermediate questions. So for those who have maybe joined a little later, I'm going to leave the link to the HackMD again here in the chat. Okay. And there's some intermediate questions in there where I'm asking about community building, because this is the next part that I would like to talk about. And this is I can make this a bit shorter, Dave, in order to keep within time, but I think since we already had a bit of question answering in between, that should be fine.
That's fine. You're mixing it in. So if we try
Okay.
and finish on the hour, then that'll be perfect.
Excellent, will do. Okay, we have quite some people here who have built a community before, and some who haven't. I'm going to share my screen again so that you see what I see. So we have quite some people who have built a community before, some haven't. And there's quite some insights on what the hardest part about community building is. Getting others to become involved is one, and identify common goals. Yeah, again, getting people to join, onboarding, keeping momentum. This is definitely something that I would agree with as well. Yeah, not having to sustain it anymore might be nice. And how can we build more inclusive communities? People are saying involving those that this involves, very true. Identify goals which are common to a broad spread of people. Have an easy read. This is about, has to be a pitch to your audience. Excellent. Yeah, I completely agree with everything you say. So very cool. And then I'll get the slides started again, because I want to talk a little bit about the part of the Turing Way, which is the community, because I think that's one of the things where we could definitely learn from, because I think they're doing such a great job at, yeah, building this cool collaboration where people all over the world are contributing. And I want to share a little bit about what I think is great about it, not being involved in like leading the project, but as like someone who's, yeah, who just got involved and who got excited about the project. And this is actually one of the images that are in the book. So these are the kinds of images that we're using to explain the different things. And I really like this image of having the iceberg, and there's some parts that everyone sees when they think about collaboration, but there's so many things that people might not be aware of usually when we're talking about building a great community. Things like treating each other nicely, building diverse teams, having a code of conduct, having an inclusive workspace, or being explicitly open for contribution. And especially this last part is something that I think the Turing Way does really nicely, and just like making me feel like as an outsider that I can contribute anytime, that it's just like not an issue at all, and that that people get very excited when I open issues on the GitHub or just get involved in discussions, that there's just like this openness to people from the outside, which I think is really, really great. And so, yeah, how does that work? How does the Turing Way work in growing this inclusive, open community? And it's really rather simple things, I think. For example, there's these meetings that you can just join, and people will in the beginning explain to you what the meeting is about, how it works, and get you started. Also walk you through the basics of, for example, using GitHub, because we're writing the book collaboratively on GitHub, but not everyone who joins the project already knows how GitHub is used, right? So this is really cool. And this is also something where there's like this really cool circle, because the book itself explains how GitHub works and how you can contribute to the project. And then people can start contributing to the project and improve the chapter of how GitHub works and how people can contribute to the project. So this is a really cool, nice circle of like, you can get involved and immediately have some impact. And especially, I think, as a new person, it's always much easier to see like where there's gaps, for example. So if I'm new to GitHub, it's for me very easy to see what I need to know, what else I needed to know to be able to work on this. So I heavily encourage people to work on book chapters also that are new to them, because it's very easy to spot what you find confusing, right? So this is something that I really enjoy doing as well. Myself is working on things that I don't understand yet. And this is a nice way to learn and also improve the book itself. What is really nice about the Turing Way is also that there's networking involved. So there's calls that you can join. There's these book dashes you can join. There's Twitter that you can interact with. So there's a Twitter channel. Yeah, there's a chat. There is a newsletter. You can interact through GitHub issues. There's just various ways of getting involved with the community. And yeah, I met so many amazing people through the Turing Way. And also, yeah, like to talk to them on different things as well. Yeah, we help each other grow. We're sharing best practices. And this is also what I meant with the full circle earlier. And yeah, the Turing Ways is very welcoming and full of opportunities. And this is where I come back to showing you how can you figure out like where to find all this information about growing a good community, is both in the community handbook, which describes how the Turing Way itself is built, but also within other chapters like the guide on collaboration. So if you're now hooked and you're excited and want to get started and help with the Turing Way as well, here are a few suggestions how you could get started. For example, if you read the book and you find a typo, then you can try and fix it. And this might be scary in the beginning, but just like open an issue, start a conversation with people, say you don't really know how to fix this typo, and then there will be someone there to help you. For example, flag unclear or duplicated information in the book. As I said, as a newbie, it's often easier to spot these things. Maybe go through the issues in the Turing Way and fix one. Create a pull request if you feel comfortable with that, or join one of the meetings, online meetings, and ask people how to do it. Or write down your personal experience of reproducible research. So we're collecting also these stories, and they're going to be part of the book as well. And otherwise, there's also more info in the GitHub, for example, on the online collaboration cafe, where you can find out ways to get involved. What I really like as well about the Turing Way, since it's such a big project and so many people involved, is that there's this very clear path of how you can get acknowledged for contributing. And that is something that you can see on the GitHub as well. So what you see here on the right-hand side are all the little pictures of the different people who have been contributing to the project. And here's a little screenshot of like a smaller version of this, and it shows some emojis, and each emoji means something what you did. So for example, a bug means that this person fixed something, for example, a typo or something bigger as well. This emoji that does this means that you had an idea that got into the book. So I really think that's very nice to, yeah, acknowledge all the contributors, how big or small the contribution might have been. This is something you can also take for other projects, which I really like. So now I want to finish up with some final questions. I don't think we have, so final questions for me. I don't think we have the final time for the final questions for you, but this was something that I kept in there to make sure that we have something interesting to do for all this time. But since you asked so many interesting questions, I don't think we're going to need that. And with that, I just want to finish up saying thank you for having me. And also, I published a new podcast, which is called Reboot Academia. Unfortunately, it's in German, but maybe someone here speaks German as well. So if you do, this might be interesting for you.
So any last questions? It's amazingly unusual way of doing it. Actually, it's very interesting to watch, and a good format. Can I ask a question?
Sure.
So one of the things is when you were talking about retaining data sets and reproducibility. I mean, quite a lot of things we do in healthcare research definitely don't do that, because the very processes that you go through to acquire data will eventually delete that data for issues of confidentiality.
Yeah.
What's your view on that? I mean, is that bad science, or what's that? Because you definitely can't reproduce.
Yeah, no, I don't think that's bad science. I think that's very good science, actually, is because I think privacy of patients is more important than full reproducibility over a long period of time, right? So I don't think that's in conflict at all. I think there's good ways of like still sharing with other people out there what you did exactly. So if you already share the code, for example, it's much easier for me to understand what you did, even if there's no data out there. If there's like a version of the data set that's just the headers, right? Just like the information on what columns you had that you used for the analysis. That's already more informative to me than not having anything at all, or having simulated data, as I said, is something that's super helpful for like other people to understand what you actually did in your research. Because honestly, if you just have the method section in a paper, that's always too short to understand really what the person did. So having at least the code is, I think, something that we should aim for in the future. Does that answer your question?
Yeah. That's good. But you're in control actually of the questions. I shouldn't be. Are there actually I will, because we're nearly finished now. Actually, I think for time. Are there any other questions? I don't think there's anything new crept in, other than people saying really interesting talk and nice things like that. So that's good.
Thank you.
Any last questions in the chat? Gone. So I think that's it, Heidi. Oh, wait a minute. Oh yeah, yes, and Serena's put in the traditional final that tells you that's the end of the session, and you get the final bit saying what the next seminar is going to be, so people can read that. Next one is on the 16th of November at 3 o'clock, and there's the link to register. So thanks very much, Heidi. That was very interesting.
Thank you.
And thanks for the refreshing different format. That was very good. And thanks everybody for turning up. Enjoy the rest of your in Edinburgh very wet afternoon. See you next time.
Bye bye from sunny Munich.